So, like I mentioned, doing this time-resolved anisotropic solid-state high-harmonic generation as well as cryocooling, because we can't access these magnetic degrees of freedom without, a closed cycle helium cryostat. And the sort of long-term goal, something else I've been working on, is developing a sort of purpose-built high-field terahertz spectrometer that sort of lets us couple in either an optical excitation or a mid-infrared driving field to drive high harmonic generation. But basically something that's designed such that we can get the highest field strengths possible at a cryogenically cooled sample. And so basically most of the parabolic mirrors will be in a vacuum chamber, and generation will still be outside of vacuum. But one of the things that I'd like to pursue in my independent career is nonlinear terahertz spectroscopy, sort of in the realm of what Keith Nelson is doing nowadays. So driving, second harmonic generation, terahertz second harmonic generation. Also, in principle, one could do terahertz high harmonic generation, which is, people have done some harmonic generation in the terahertz range, but haven't quite got to the making a frequency comb yet. And you need a really high field strength source for that, and the ability to sort of pull out your comb. And so the idea would be that if you could do a 2D terahertz experiment, you would be able to see the harmonic emission on sort of diagonals. So long term, that's something I'd like to try. I mean, so with this solid state high harmonic generation experiment, so you can extract from the angular anisotropy the curvature of these bands, like I mentioned. And so basically, like with this technique, so you measure an emission spectrum, and then you need at least one other variable to actually sort of pull out this information. And so when we do it in the mid-infrared, we sort of rely on angular anisotropy to extract this information. So we're basically probing in K-space. But one thing that we're missing that also encodes a fair amount of information is the phase of the high harmonic emission. So we're measuring in the UV visible, so there's not really phase resolving any of that. But with terahertz, as this sort of the selling point is you measure the field directly, so you don't lose that phase information. And so that's something that really hasn't been explored in this field. It's something I'm interested in. Yeah, so